everyone. In this video, we're going to talk about quadratic-like equations. We're going to see what they are and how to solve them. So the first thing we need to do is determine if an equation is what we call quadratic-like. So not all of them have three terms, but we're focusing on ones that do have three terms in this video. So notice in this, we have three terms, and it does equal 0, which is our last thing. Okay, so we have three terms in that expression. The exponent on one term is twice as much as the exponent for another term. Notice this exponent, if I multiply by 2, I'll get 2/6, which is 1/3. Okay, so that is done. Okay, the third term doesn't have a variable. Notice this -2 does not have a variable, so that's good. And it should equal 0, or it should be able to be reorganized so it does equal 0. So hypothetically, if this 2 was over here, I could subtract 2 on both sides and make it equal 0. So you should be able to reorganize it so it equals 0. Now let's take a look at how to solve them. When you're solving, you start off by replacing the old variables with a new variable so that it represents a quadratic. You need to solve that quadratic. You can use the quadratic formula, you can use factoring, you can use completing the square, however you want to do it. Then you can change the variable back to what it used to be and then finish solving. Okay, so let's take a look at an example. Step 1 is always to make sure it fits the pattern. So it does equal 0, it does have three terms, and this exponent times 2 equals that exponent, and this last term does not have a variable. So that fits all of those qualifications I just told you. So step 1, I'm going to take this variable right here and make that equal another variable. So I like to use w's for some reason. It's just how I learned it. So I'm going to say w is x squared. Now because this fits the pattern, this term is going to turn into a w squared. So I have w squared minus 8w plus 8 equals 0. And generally what's going to happen is you're going to have something in this format where you have a plain w here, because that's the thing that we made equal w, and this term is going to turn into a w squared. Okay, so I did step 1. Step 2, I need to solve this. Now this cannot be factored because there's nothing that multiplies to positive 8 and adds to negative 8. So I can't factor it, but I can use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, next I need to solve this using this quadratic formula. Now just a reminder, this coefficient is a, this coefficient is b, the negative 8, and this number is c. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. 2 times 1 is just 2. Okay, this becomes 64 minus 32, which is 32. Okay, and then the square root of 32 can be simplified to 4 times the square root of 2. And then this whole thing can be reduced. Both the 8 and the 4 are divisible by 2, and as long as you're able to divide both terms by this number, then you can reduce it. So 8 divided by 2 is 4, and 4 divided by 2 is 2. Now notice I didn't have to reduce the square root as well, because it's inside the square root, it is attached to the 4. As long as one of these numbers is divisible by 2, and I divide one of those numbers by the 2, then it has been reduced properly. Okay, so this is what w squared equals. I just need to go up a little bit on this. Okay, w squared equals this thing. Okay, or sorry, w equals that thing. Sorry. So 4 plus or minus 2 square root 2. Now, I have solved my quadratic. I'm on to change the variable back. This w was an x squared, so I'm going to replace it with x squared. Now, to get x alone, I have to do the square root of this thing. And when you do the square root, you need the positive or negative sign on it. So this is 4 plus or minus 2 square root 2. Now, if I wanted to write out all of the possible solutions for this, I would write the positive square root of 4 plus 2 square root 2, the positive square root of 4 minus 2 square root 2, the negative square root of 4 plus 2 square root 2, and the negative square root of 4 minus 2 square root 2. Okay, these are all 4 solutions of this equation. Now you may remember for polynomial ones that have whole numbers up here, this exponent tells you how many solutions there are. These are all 4 solutions of this. Okay, notice I did the positive one with both options here, the negative one with both options there. Now let's take a look at our next example. We already went through all of the qualifications on this, so we know it meets our needs. So it is quadratic-like. So we're going to skip right on to step 1. Replace the old variables with a new variable so it represents a quadratic. So again, I'm taking this middle variable, that's the one I'm always using. I'm saying w equals x to the 1/6. Now I'll rewrite this in terms of w. It's w squared plus w minus 2 equals 0. So this term always becomes a w squared because it fits the pattern. This variable gets replaced with a w, and I keep the minus 2. Now this can be solved using factoring because there are 2 numbers that multiply to negative 2 and add to positive 1. And that would be positive 2 and negative 1. Okay, now if you wanted to, you could solve this, but what I'm going to do, I prefer replacing with this variable first and then finishing my solving. So I have x to the 1/6 plus 2 equals 0 because I want to find the zeros here. So I just took this inside thing, I replaced the w with an x to the 1/6, and I made it equal 0. And then for this one, I'm going to do x to the 1/6 minus 1 equals 0. Okay, so I'll subtract 2 on both sides. Now remember, this is a 6th root. The 6th root of x equals negative 2. And then I have to put this to the 6th power, okay, to get rid of my 6th root so it cancels. So I'm going to raise this to the 6th power. I'm going to raise this to the 6th power. So x equals 64. Okay, so that is the 6th power of negative 2. Over here, I need to do the same thing. So I'll add 1 on both sides, and I'm going to rewrite this as a root. This is the 6th root of x equals 1. I'll raise everything to a 6th power to get rid of that 6th root, so it'll cancel out. So I get x equals 1. Now the final thing I should do is double check if I put this in, does it work? And if I put this in, does this work? Now 1 to any power is 1. This is 1 plus 1 minus 2. And that is equal to 0. So x equals 1 does work. Now 64 to the 1/3 power plus 64 to the 1/6 power minus 2 does not actually work. If you take it and put it into your calculator, it doesn't work. So this is an extra solution. It does not work. This is our only answer for this one. So that's it for this video. Let me know if you have any questions or if you need some more help with this.